A party. 50 people in a room. Engineers near the bookshelf comparing side projects. Designers by the window sketching on napkins. Marketers at the bar networking. Everyone has a name tag with their profession. Someone new walks in without a name tag. Two questions arise. KNN asks, "Who is this person like?" K-Means asks, "What groups exist here?" Same room. Same people. Same spatial information. Fundamentally different questions. The new guest walks through the door. No name tag. She's carrying a laptop bag and wearing a conference t-shirt. Is she an engineer, a designer, or a marketer? K nearest neighbors doesn't analyze her accessories or make assumptions. It simply looks at who is standing closest to her in the room and what their name tags say. K equals 5. Find the 5 people standing closest to the new guest person 1. 2 feet away. Name tag says engineer. Person 2. 3 feet. Engineer. Person 3. 3.5 feet. Designer. Person 4. 4 feet. Engineer. Person 5. 4.5 feet. Engineer. 4 out of 5 nearest neighbors are engineers. KNN predicts. The new guest is an engineer. Simple majority vote. No formula was derived. No model was trained. Just proximity and democracy. The choice of K matters. K equals 1. Look only at the single closest person. Fast. But what if that one person is an outlier? An engineer who wandered over to the design corner to borrow a pen. You'd misclassify the new guest based on one fluke. K equals 50. Average over half the room. Too smooth. Every new guest gets the same prediction because the neighborhood includes everyone. The sweet spot is typically 5 to 15. Chosen by cross-validation. Try each K. Measure accuracy on held-out guests. Pick the K that performs best. How do you measure closeness? In the party room, it's physical distance. Feet or meters. Euclidean distance. Straight line between two people. Manhattan distance. Walk along the walls. No cutting through the dance floor. In gene expression, each person has 20,000 measurements. Euclidean distance works but is dominated by highly expressed genes. Cosine similarity. The angle between two expression vectors. Captures profile shape regardless of magnitude. A cell expressing gene A at 100 counts and gene B at 200 has the same cosine. Similarity as one expressing A at 1000 and B at 2000. Shape over scale. In 2 dimensions. The party room. Proximity is intuitive. 5 nearest neighbors are genuinely nearby. In 50 dimensions. 50 gene expression measurements. Something strange happens. Everyone is roughly the same distance from everyone else. The nearest neighbor and the farthest neighbor have almost identical distances. Proximity becomes meaningless. This is the curse of dimensionality. The solution. Reduce dimensions first with PCA. Project 50 genes onto 5 principal components. Then run KNN in the 5-dimensional space where distances are meaningful. KNN. Find similar people. Copy their label. No model is trained. KNN stores the entire training set and computes distances at prediction time. Lazy learning. It's supervised. It needs labeled examples to copy from. It asks one question. Who is this new data point most like? The answer comes from the neighbor's votes. Simple, intuitive, and surprisingly effective for cell type annotation, drug response prediction, and any task where labeled reference data exists.